Alright, in this video we're going to continue working on Lab 4. The part I'm creating here is the well seal, which is step 7 in your lab manual. So I've created a new part here. I'm going to create a new sketch on the front plane. So sketch front plane. Now the first thing I'm going to do is something that we haven't taught you guys yet, but you should know it makes revolves a lot easier to do. It's also crucial in this step because there's no other geometry to reference as your axis for the revolve. So we're going to go to line, right? And up until now we've just created standard lines, right? Lines that create geometry when referenced for features. Now if I select the drop down line here, the little arrow, there is a center line. So when I select center line, what it's going to do is it's going to create, consider it like a reference line or construction line. All this does, you can see here, right, is create a dashed line which will be used to reference features when we go to create the revolve. So what do I mean by that? I mean, when I create the well seal, right, so something along the lines of this. Now of course I'm going to have to smart dimension this to scale, but when we do these kind of features and we revolve them, we have a axis which that part is revolved around, right? So usually if we were to do a part like this, we would use the center axis here and it would spin around and give us a little T looking feature. But in this case we want to have a hole in the middle, so we could revolve the whole thing around the center with, you know, the larger diameter, so 35 plus the 25 offset here, and then create a hole using just a new sketch on the top of this part and put a hole, extruded hole through it. But instead what we're going to do for this one is a little bit more of a complicated revolve, where we have an offset from the interior of the part and the revolve axis. So okay, so here's the profile here for my revolve. Now what do I mean by that? I mean, when we go back to our sketch and we click revolve, it automatically selects that center line that we created as the axis. So you can see here now this revolve has a hole in the middle, right? When I click OK, right, does everybody see how that is? We have this hole in the middle because the closest line, right, this line here that can be used to create actual geometry, remember the center line doesn't create geometry, the closest line is offset from the axis, which means it sweeps around in that circle, leaving this gap in the center. So like I said, we could have just created a full revolve where this interior line was here and then create a new hole, or we can do it all in one step using that center line. Once you complete this, you can go ahead and save this as the well seal. So file, save as well seal. And we'll go ahead and move on to the next part, step 9. So we'll create a new part here. This one's been giving a lot of trouble to people. I think there's some confusion when you're looking at the lab manual and what does it mean, how do you create these parts, like what is the geometry is referencing. So I'll just go quickly through this here. We'll create a new sketch on the top plane, just a simple circle like that, a diameter of 60 millimeter. Okay, now we'll extrude this with a mid-plane condition. So features, extrude. Remember that mid-plane means that the extruded surface goes in both directions from our sketch, and the depth of the mid-plane is the total length of that extrusion. Okay, so if I select 100 millimeters, which is what's asked for, whoops, that's what's asked for in the lab manual, right? So select 100. That means it extrudes 50 millimeters in this direction and 50 millimeters in this direction. You don't automatically have to select 50 and then do an extrusion in two directions. You just select mid-plane, it keeps your sketch in the middle of the extrusion, and the total depth here, this depth here, D1, is the depth from the top of the extrusion to the bottom of the extrusion. Okay? Then I'm going to select the right plane here and create sketch again. So we have this new sketch right there. So we're looking at the side of our T. I'll create a new circle of 40 millimeter diameter right at the origin there. Okay. Specify this as 40, right? can see that I selected the origin. Then I'm going to go ahead and extrude this by 80 millimeters. So just select here, 80, and it should look something like this. Okay. Now I'm going to go ahead and shell. Where's shell here? Right there. Okay, I'm going to shell this part, selecting these faces here, the top face, the side face, and the bottom face. Remember that the shell removes all the material on these faces, but leaves a certain amount of material around the other faces, which we'll select as 5 millimeters here. And press OK. So there we go, we have this T here. Now we'll go ahead and use a fillet. Alright, so we'll select fillet and we'll select this curve here. And we will select a radius of 5 millimeters. 5 millimeters. Keep all the other parameters to default, which is a constant fillet, full preview. Keep all that defaulted. If yours doesn't have full preview, just select full preview so you can see what's happening, but it should be defaulted to on. Okay, now in the lab manual, the one that's posted on Blackboard, you'll notice that there are lines on the tangent edges so you can see those curves. So if you want to see that, remember that we turned that off in the first lab. You can go up to View and Display and then just select Tangent Edges Visible, and they'll pop right back up so you can make sure that yours looks exactly like in the lab manual. Okay. Now we'll save this file as T. So File, Save As, T, and we'll move on to the next part. So File, New part. We'll create a sketch on the top plane. Simple again, just 2 circles offset from each other. This first one here is going to be 45 millimeters in diameter, and the larger one is 50 millimeters in diameter. Then we'll go back to features and extrude and set this extrusion to be a 200 millimeter extrusion. Okay, just zoom out there, and we'll save this as our guide cylinder. Okay. Now we'll cover the stroke slide, so new part, sketch on the front plane because we're going to do another revolve. So same thing as last time, I'm going to select my center line and just draw that right down the middle there from the axis. Then I'm going to create roughly what the profile looks like. And then I'll just dimension it to be what I need it to be. So this is a 205 millimeter total height. This interior height here is 200. The distance between the center line and that long height there is 25. The difference between this line here, oops, and the center line, that should be 20. Okay, and I believe this depth here is 5. Yep. Okay, so that looks something like in the lab manual. Now, one thing I caution you when you're building these kinds of multiple rectangle shapes, because you could build this with just a simple rectangle up top here. I'll show you what I mean. You could build a rectangle here and then create a long rectangle there. The only issue with that is that you'll find if you don't clean up your sketch, if you don't clean up your overlapping lines, you're going to have an issue where it might say that your path is not continuous when you go to create an extrusion. You might just have all kinds of errors based on the fact that you have overlapping lines. Let's delete that there. Sorry, there's one more dimension here that I forgot to put in for you, and that's from the center from our origin to the bottom of this revolve, we should have 100 millimeters depth. Okay, so back to what I was saying about the overlapping line. So if I create a rectangle here, and then I create another rectangle that goes from here all the way down to the bottom of our profile, there will be overlapping lines, right, where the two rectangles overlap. If you don't clean up those overlaps, you may have issues when you go to create a revolve or an extrusion. So it's crucial that you use the trim entities, right, and the extend entities to trim and extend any overlapping lines that you might have. What I would suggest is avoid that whole problem altogether by just creating straight line segments, right? So exactly how I did, I created one line here, all the way down, and then dimension them to be the dimension that you need for your profile. Okay, so here we can see that's what our sketch should look like, center line in the middle, and the profile. Then I'll go to feature and revolve. I'll automatically select, I'll select the sketch first, then click revolve, and there you go. Looks good to me. I'm just going to double check. Yep, matches up with the lab manual, and I'm going to save this. Oh no, my mistake, we have further steps to take. So we'll go back to sketch, and we're going to sketch on the right plane. So here's another thing that most people don't are unaware of right now. If you click sketch or anything where the dialog box pops up here on the left and you don't have any reference geometry selected, you can open the tree by selecting this arrow here. So I know I want to select the right plane to do my sketch, so I click sketch first without anything selected, and then I can just open this tree, select right plane, and create a new sketch on the right plane. Now that works for everything. If you were to say create a constraint between two parts in an assembly, you could do the same thing, right? You could create mate, then open up the tree and find those other parts. So that's always there. It just shifts, your tree shifts from here. As soon as the dialog box pops up, it shows up over here. You just have to expand it. So we'll go back here to our part creation. We're going to create a circle of diameter 30, and from the origin to the center of that circle is 75 millimeters. Okay, and what you can't see, the center of my circle and the center of the origin right there are directly in line, but of course I pre-selected that by placing my circle with the suggested line there. Now I'm going to go ahead and exit that sketch and create an extrusion by selecting extrude boss. I'm going to go mid plane with 150 millimeters as my total depth. Okay, so we see here we have this little periscope looking solid body. Now I'm going to go ahead and cut the overlapping material because we don't want this cylinder through the middle there. So to do that, very simply, I'll go to sketch, select sketch, and pick this face here. So you can see I'm sketching a new sketch on the bottom face, right? And now what I can do is I can select the convert entities button here up in the sketch tab, and I will just pick the center circle. Okay, so you can see it's highlighted in orange here. As soon as I select that and press OK, what it does is it creates a circle from that edge entity. So this was originally just an edge in our solid body, but I created a new sketch plane, right, which gives my my sketch a reference to this plane. Then I'll click convert entities, and what it does is it just takes that edge and creates a circle based on the underlying edge. Very simple. Of course, you could have just created a new circle, but this is just a very quick and easy way to get the same geometry. Then I'm going to go ahead and click exit and go back to features, extruded cut, and now I select a cut depth of 150 millimeters. At this point, it doesn't really matter the cut depth as long as you don't cut through the top here. Remember that we want this overhanging feature, and that we also want to cut through the tube here, the cylinder that we created. So as long as you're greater than this distance here and not all the way through that edge, you'll be fine. Of course, the default's 150, which works perfectly fine. So we'll just press OK. So now you can see we have a clear cut hole right through the bottom. matches up exactly with step 17 of the lab manual. Just double check to make sure yours looks like this. So now what we'll do is we'll go back to these sides here, the handle-like cylinders, and we're going to create a new sketch on the edge. Okay. So similarly, I created a new sketch. Now I'm going to click Offset Entities and select the outside circle here. It's the only circle in this case. And I'm going to set my depth as, I believe it's 3 millimeters. So 3, there we go. Okay. Now we see that the new line, which is the yellow line, is on the outside of the blue line, which you can see here is the edge of our previous extrusion, right? So what I want to do is I want to select reverse, so that yellow line is on the inside of that blue line, right? So you can see that right there. This yellow line is on the interior, because what we want, I'll press OK, what we want is a 24 millimeter diameter circle on the inside of the larger 30 millimeter diameter circle from before. Okay. Now once we get past this point, we're going to go ahead, exit the sketch, click feature, click extrude, and we're going to extrude a blind depth of 20 millimeters, right? Okay, we get this very simple extrusion here, and press OK. Okay, so we can see here, this is the small cylinder is going to be the new face for our threads that we'll create. But first, we're going to duplicate this to the other side. Rather than just drawing a new circle and extruding it, we're going to check mirror. We're going to select the extrusion. Whoops. We'll select the extrusion first, then select mirror. Okay. And then we're going to select a mirror plane. So this is one of those key times when you can use the tree right here to help yourself. So it's asking me for a mirror face that I should select to mirror about. So I open up my part tree here, I go down to the right plane, and you can see there it highlights the right plane, and it automatically creates a preview of where the cylinder will go once I select mirror, and then I can press OK. Alright. Next step after this, we will have to create the threads. So this is something that has been giving students a lot of trouble so far. It's actually pretty simple to do a thread. We're going to use a standard thread, standard metric thread. To do that, we'll go up to Hole Wizard under the Features tab, select the drop down, and select Thread. And then we're just going to select, it'll give us this error, don't worry about this. It's just telling you that these are nominal thread profiles and that you shouldn't use them for production quality threads. This has no consequence on you guys in your lab, so just go ahead and press OK to skip that. And then select this edge here. Now it's automatically generating a preview for the defaulted thread type. So I'm just going to go ahead and change this to a metric die. Okay. And I'm going to select the size to be M24 by 2. Okay, so we'll zoom down here to M24 by 2. Okay. And I'm going to select the end conditions for blind and 19 millimeters. So right here, I'm just going to set this to 19. Okay. So there you can see it's generating the preview of the thread that it's going to create, which will go down to this other cylinder here. Make sure to that your thread method is cut thread, which means that it's going to cut the thread into that cylinder rather than extruding the thread away from it. And then you can go ahead and press OK, and it should work. There you go. Okay. Now this is just so you guys can learn how to do threads. In a lot of applications, if you were to create, now of course in this case we have to create our own custom thread, but if you were to use, say, a bolt or a nut, which we will later on in the lab manual, you can just pull these up from the design library, which is available through SolidWorks, which has all these standard parts already CAD'd out, and you can just copy and paste them. But in this case we have to create our own thread because this is a custom object and we can't use those design libraries. However, because it is a standard thread, this M24 by 2, 24 being the nominal diameter, 2 being the thread pitch, we just select in our thread dialog box here 24 by 2, and it creates the profile for us. So very simple. Okay, now just quickly repeat that on the other side. Alright, 24 by 2. Okay, looks good. So this is probably the most confusing part that I would say in Lab 4. Once you're done this, you can just go ahead and save the part. Remember to save this as the what is the name we're giving it to it here? Let me just check. We're calling this one the stroke slide. Okay, so when you go to save, just save this as stroke slide. If it asks you to rebuild, that's not a problem. So that's your finished stroke slide. Like I said, this is probably the hardest component that you'll have to create in this lab. So once you're past this, you're kind of over the hill, and everything else is pretty easy.